Kirchhoff voltage law, KVL. So KVL is a duet of KCL. So we know KCL already, and KVL has similar mathematical expression. KCL applied to nodes, KVL applied to loop. So nodes and loop are duet pair. And later on, when we talk about methodology to analyze circuit, mesh analysis and nodal analysis apply to nodes, and mesh analysis apply to loops. So how do we apply KVL? Here are some tips. I choose any point. I start any point in the loop. I start walking, okay? The direction of walking, I do clockwise, this direction. For example, here, this circle, I walk, okay? I walk to here. When I encountered a voltage plus sign first, that I will have VR plus sign. And then here, and go again here, nothing, no voltage. And then here, I will have a voltage here, but I come to cross negative sign first. So in this case, that will be minus Vs. And then pass this device here. And then I come back to the same place. So my loop is finished. Remember, voltage difference at the same point is 0. So therefore, we have VR minus Vs equals 0. That have Vs equals to VR. We know this concept a long time ago, that here there's a source here, the voltage is Vs, and there's no other elements here, no other elements. So what's the voltage on here? VR. Of course, that equals to Vs. Right? Of course, you have the same sign here, you know, the positive sign here. All of this can be understood by applying KVL. So we will have here minus plus VR. So let's look at another example. I'll start this point here. You can start any point, no problem. Okay, so I'll start this point here. First of all, when I walk here, I encounter VR1. I encountered positive sign first. So therefore, I have plus sign here. And then I keep going. And then plus sign here, VR2 plus. And then here, I'll keep going. Positive sign here, VR3. And then here, positive sign here, Vs2. And then here I encounter positive sign first, plus, and then just keep going. Now I encounter negative sign first, therefore I should have minus Vs3, and then keep going. And then here, this element I encountered negative sign first. So negative sign first, negative. And then I come back to the same place. So it's equals to 0. This is how we apply KVL. Let's look at another example of using KVL to figure out terminal voltage. This is a terminal voltage. VAB. Okay, so this has been always confusing part. Imagine here, this is a voltage here between A and B. There's a voltage here. I will apply KVL. Okay, so I can start walking. Yes, start walking here. This direction. Start walking this point. I start walking this direction. Clockwise, right? First of all, here I encounter V1, that's positive, right? And then walk, and then V2, and then here Now I encounter negative sign first, V3, and then I keep going. And then here, imagine here, this is a voltage here. You encountered a negative sign here first. So that will be minus VAB. So now there's a voltage here on this branch, on this terminal here. You have to imagine that there's something connected somewhere else here, some other circuits here. I don't care. So this is a terminal I want to consider. That's my interest. I want to find out the voltage between point A and point B, or terminal A and terminal B. And then, okay, I keep walking here. I come to the same point. I finish this loop. That equals 0. Okay, so if we solve this, so VAB, you move VAB to this side, V1 plus V2 minus V3. So this is exactly the same here. We can simplify the circuit. I have terminal here, A and B, this still VAB. What is VAB equals to? So it's equals to a voltage. What is this voltage? That's V1 plus V2 minus V3. So this is how we figure out the terminal voltage. People will say, okay, that's easy. I don't have to use KVL. That's okay if you can figure it out correctly. So people who do not use KVL, they will say, okay, so that's their source. This is a positive. So of course the voltage will be V1 plus V2 and then minus V3. This is negative. Now, if the question is changed, yeah, I mean, if the sign of this VAB is changed, it becomes this is a negative and this is a plus. Then a lot of mistakes made in this case. If this become negative sign, this is become positive sign. Here we want to have a method. No matter which sign of VAB, I don't care. I walk through a loop. I walk through a loop when I encounter a positive sign of a voltage, any voltage that's plus sign. When I encountered negative sign first, that's a negative sign. There shouldn't be any mistakes made. That's why I say that's a safe method to figure out the terminal voltage.